Hello, in this video, we are going to learn about jet transform. Transform technique is an important tool for the analysis of signals and Laplace transform analyze the continuous time signal. But to analyze the discrete time signal, we need another technique, and that's why we are going to learn the jet transform. So jet transform analyze the discrete time signals and systems. So we should know what is the meaning of discrete time signals. So in discrete time signals, so different samples are represented here like this. This signals at a discrete point only is defined. So it is called as discrete time signals, and jet transform is built to analyze the discrete time signals. Jet transform analyze a discrete time signal in a frequency domain with a valuable technique. It have a valuable technique to analyze a discrete time signal. Jet transform is a powerful mathematical tool for analysis of linear time in various discrete time systems in the frequency domain. We can analyze the signal in the frequency domain. Now we will see what are the advantages of jet transform. Discrete time signal and LTI system can be completely characterized by using the jet transform. So jet transform is used to characterize the discrete time signal and the LTI system also. We can give the stability of define the stability of LTI system by using a jet transform. So stability of LTI system can be determined by using the jet transform. The signal, the system, the LTI system is said to be stable if the ROC is remain inside the circle. So this is the radius of the circle, and the ROC is inside the circle. So then that LTI system is called a stable system. Mathematical calculations are reduced by using the jet transform. Discrete Fourier transform and Fourier transform can be calculated by using the jet transform. We can also design digital filter by using jet transform. We can also get the solution of differential equation by using jet transform. Now after this we can define jet transform. We will see the formula of jet transform. Jet transform of discrete time signal x of n is defined as x of z is equal to summation from n equal to minus infinity to infinity x of n z to the power minus n, where z is a complex variable. This is called as two-sided jet transform, as it is defining from minus infinity to infinity. So it is defined for both the sides, for causal and anti-causal side. Okay, and if you want to define it for the one-sided signal, so we can write here formula for a causal signal x of z is equal to summation of n equal to 0 to infinity x of n z to the power minus n. So this is the one-sided jet transform. We can also define inverse jet transform x of n equal to 1 divided by 2 pi j close counter of x of z z to the power n minus 1 dz. But we generally find out inverse Z transform by using the partial fraction expansion. Now we will see what is the region of convergence. Z transform is an infinite power series. It exists for all the values of Z for which series converges. Okay, so Z transform is an infinite power series, and to exist this infinite power series, we need values of Z for some finite values of Z. Okay, so that series should get convergent. That series to exist, that series we need the values of Z. Okay, for finite values of Z. Now, region of convergence ROC of x of Z is all the values of Z for which this x of Z attains the finite value. The value of this x of Z should be finite when we will put value of Z in that x of Z. Okay, so region of convergence x of Z is all the values of Z for which x of Z attain finite value. The x of Z should be finite. Region of convergence of 6 types of signals are discussed. Now, what are these 6 types of signals? For finite duration, right-sided signal, finite duration, left-sided signal, finite duration, 2 types of signals, infinite duration, right-sided signal, and infinite duration, left-sided signal, infinite duration, two side signals, okay, or 2 types of signals. So in this finite duration, 2 types of signals, both causal and anti-causal will come. Here in infinite duration, 2 types of signals, causal and anti-causal will come. For left-sided signal, it will be the anti-causal signal, or right-sided signal, it is the causal signal. Now, finite duration right-sided causal signal. Let x of n is a finite duration causal signal. It's a sample with n samples. We can define x of n is from 0 to n minus 1. Now, Z transform is x of n of x of n can be given by using the formula. Okay, so x of z is equal to summation from n equal to minus infinity to plus infinity x of n to the power n. But we are defining this for the right-sided causal signal. So we are taking only the positive side, that is from 0 to n minus 1 samples we have taken. So x of, now we are going to put value of n. Okay, it is from 0 to n minus 1. So x of 0 plus x of 1 e to the power minus 1 plus x of z e to the power minus 2 up to x of n minus 1 z to the power minus n minus 1. So here you can write this as x of 0 plus x of 1 divided by z plus x of z divided by z square plus dash 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 x of n minus 1 divided by z of n minus 1. So now if value of z is we are putting 0, this series will become infinity. But we want finite values of x of z. Okay, to find out the ROC. This series, we need finite values of z. So if we are putting 0 here, we will get infinity. So except for z is equal to 0, the region of convergence we can define the region of convergence exists for all the values of z except z equal to 0. Okay. So ROC for finite duration right-sided signal is the entire z plane except Z is equal to 0, because if we are putting value of Z is equal to 0, this series becomes infinite. Now we can get summary of ROC of discrete time sequence. Sequence is a finite, that is right-sided or causal signal. The ROC will be the entire Z plane except Z is equal to 0. If the sequence is left-sided, that is the anti-causal signal, ROC will be the entire Z plane except Z is infinity. For finite non-causal signal, so entire Z plane except Z is equal to 0, so Z is equal to infinity. If we are talking about an infinite signal and it is a causal signal, then ROC is exterior to the circle of radius R1, where Z should be greater than R1. Infinite anti-causal signal, interior to the circle of radius R1. And if it is an infinite non-causal signal, so area in between the two circles of radius will be the region of convergence. Okay, so we will see it one by one. If finite right-sided or causal signal is there, so entire Z plane except Z is equal to 0. So we can draw an axis, and this is the imaginary axis. So except at Z is equal to 0, the entire Z plane will be the region of convergence. Okay. Now finite left-sided, if it is an anti-causal signal, it will be the entire Z plane. Region of convergence will be the entire Z plane except the Z. Now finite two-sided signal, entire Z plane except Z is equal to 0 to Z is equal to infinity. So it will remain in between just two, only Z is equal to infinity. ROC causal signal, ROC is exterior to the circle of radius R1. If this is the radius R1, this is the circle with the radius R1. So the exterior part exterior to the circle of radius will become the ROC of the infinite causal signal. If it is an infinite anti-causal signal, so interior to the circle having radius R1. So all the area inside the circle is ROC. Infinite non-causal signals, area in between two circles of radius R2 and R1. This is radius R1 and this is the circle of radius R2. So area in between these two circles, ROC. ROC of different signals. Thank you.